All right, so the lab we're going to be doing today is going to be all about position versus time graphs, which we went over the other day, okay? All the stuff that's in the analysis for this lab is the stuff we were doing with the Chromebooks Friday and yesterday, okay? Using y equals mx plus b, calculating y or calculating x, okay? Looking at the slope, all of that kind of stuff. So it's nothing new mathematically, okay? We're just going to collect our own data and then we're going to graph it. All right, so the problem we're investigating here is what the relationship is between distance and time for an object traveling at a constant speed. It's also sort of a constant velocity, but we're going to simplify it and say that this thing actually goes in a straight line, which, spoiler alert, it doesn't. Possibly something not working the way we would expect and interfering somehow. Okay? So the lab is going to go like this. I'm going to have this set up here. Okay, it's not pretty, and I'm trying to pick it up. It's probably dangerous to do so. Okay, so I'm going to have this set up here. I'm going to have this powered cart connected to my data logging cart via a meter stick. Because when I tried this with a string, it really sucked. Because the cart would go and yank on the string, and then the cart would try and catch up, and then it would fall behind, and then it would bounce off the string again, and it was just really, really bad generally. So we won't do it that way, because it didn't work very well. So we instead have a fixed fifth wheel style hitch, okay, that we're going to use, okay, to tow the data cart behind it. Right? So the data cart is going to transmit data about its position and time to my phone via Bluetooth as it goes down the atrium. Okay? And we're going to let it go for probably about 10 seconds. Okay? We're going to do that with 4 different carts. The carts are not the manipulated variable. Okay? I'm telling you that right now. The carts are not the manipulated variable. We are not comparing the 4 carts. I just want to have 4 sets of data for you to analyze. Okay? So I want you to think about graphs and what we talked about with graphs. Which variable, manipulated or responding, goes on the x-axis? Manipulated variable goes on the x-axis. Okay? The responding variable goes on the y-axis. That way, any graph shows us what the effect, let me put that on the top of it, okay? What the effect of my manipulation is on my response. Okay? Everyone follow me there? Okay? So the 2 variables that we're comparing here are time and position. So you're getting a freebie here. Time is our manipulated variable. Now, people have trouble with that, okay? Because they picture me manipulating time somehow, okay? I'm not manipulating time. I'm not making it travel faster or slower. I'm not going forward or backward in it, okay? Well, I'm going forward in it, but only at the rate it normally goes forward, okay? I'm manipulating time by establishing my experiment will be 10 seconds in length. Okay? That's how I'm manipulating time. As the experimenter, I am determining the length of time that the cart can travel. Will that influence how far it goes? Yes. Okay? The response here will be how far it goes, or its change in position, more accurately. Okay? Everyone follow me there? So I'm just giving you 2. Things that need to stay the same during a trial. Okay? We are going to conduct this experiment in the atrium. Okay? We are not going to stop the trial in the middle and then put it on a hill, okay, for the second half of the trial. We're not going to change the surface that it's being towed over. Okay? All of those kinds of things are going to stay the same because they could affect, okay, the rate at which the cart travels. And we want the rate at which the cart travels, there's a special name for that, to stay the same. throughout the experiment. Otherwise, we won't get a linear line. Okay? We need this thing to travel at this special constant rate whose name I shall not mention, but you will know. Okay? We need that to stay the same. We don't want the cart to accelerate. And it doesn't. That's why we use these guys. All right. So that kind of outlines our procedure, outlines our variables. Okay? For our hypothesis, okay, we need our if, and then statement. Okay, and our if part, okay, needs to describe what happens to position for an object traveling at a constant speed. Okay? That's what the if part needs to say. So if an object traveling at a constant speed does the following. Okay? And a cart's allowed to travel at a constant speed down the atrium with its position and time measured. That's what we're doing. That's the experiment briefly. Okay? Then, tell me how I could calculate its speed / velocity from its position time graph. Okay? So, okay? So, specifically, you'll want to mention this in the then part. Some part of that equation represents the velocity of the cart. What's wrong with it?
They're not loading. It's just
Yeah, Wi-Fi.
I'm still doing it.
So you want to talk about y equals mx plus b. Specifically, if you're telling me how you're going to calculate v, you should probably tell me what part of that equation would represent v and how you would get it. Okay? In other words, do not talk about v equals d over t. I do not need a graph to calculate velocity using that. And the whole purpose of this is to use our graphs to get the velocity, not just our data. Okay? All right. When we get back, I'll have to quickly edit the data to crunch it down, and then I will include it in Google Classroom. Okay? And what you will have to do, okay? So I've included the Google Doc that you're currently working in, and I've included a Google Sheet as well. Okay? That you're going to have to copy the data I put in here into, because the file I'm going to put in is going to be read-only. All right, so just go into that read-only file, highlight all of the data that's still going to be in there, copy it over and put it in your spreadsheet. Okay, and then you can start building the position versus time graph from there. All right, it'll take me about 3 or 4 minutes to get that data edited and ready, and then you can just copy it over and get going. Okay? In the analysis, as I was saying before, in the analysis, it's all stuff that we've done. Okay, question number 1, show how you would calculate the slope of each car's line on the graph. All I want from you here, okay, is to manipulate y equals mx plus b for slope. Okay, so whatever part of that equation is the slope, I want it set up for that. Okay, so whatever slope is equals, and then you have the equation beside it, okay, and then the value of it. Don't recalculate that value, because Google Sheets is going to calculate it for you. Don't go trying to put data in to that equation. It's already going to be there. So that means you can leave some of the variables as letters. Okay? If you go plugging in numbers from your data, those numbers are not on the line. And they will give you a slightly different number, and I don't want that. Okay? So Google Sheets is going to tell you, okay, what the slope is. You need to set it up so that the equation is manipulated for that number and put the appropriate units on it. Okay? 2 and 3, okay? You're going to have 4 calculations each for 2 and 3. Show me those calculations. Okay? You're calculating for each car how far it would travel in 150 seconds. Okay? Or another, actually you'd be calculating its final position after 150 seconds. Okay? And using the equations for each car, calculate how long it would take the car to travel 100 meters. Another 4 calculations. It's the same calculation 4 times, but okay, show your work. Questions there? Okay, and then conclusion and evaluation, same as always, copy paste your hypothesis, tell me why I can accept or reject, okay, and then evaluation, sources of error. Now, this is what sometimes happens when we go out into the atrium. Because of the nature of this experiment, there's only going to be a couple of us that are busy, okay, and the rest of you are going to kind of be watching. I need you to be A, quiet in the atrium while we get this done, okay? And secondly, I need you to watch this, because this is where you'll figure out what your sources of error are. Okay? If you're not paying attention to the experiment when it happens, you won't get the sources of error for the evaluation part. Okay? Or you won't get the correct ones anyway. Okay? So make sure that you're paying attention out there. Yes? Okay. Last thing. We are going to have to walk in the hallway past Mr. Dickey's room to get to the atrium. Please be silent as we go to the atrium and pass his room so that we do not disrupt his class. We all get very annoyed when loud people go by our classrooms every time we do our job. Okay? Okay, if you go back into the main screen, okay, for this assignment, you'll see now that there's also a file, a Google Sheet called Graphing Lab Data 2020. Okay, so it was from like during the pandemic when I had to do this lab by myself and send everybody the data. Okay, so this data will work, but it does have 5 runs, not 4. You'll only have to do 4. Okay, so here's what we're going to do. We're just going to open that file up as well as our Google Sheet. Okay, and we're just going to take the data for the first 4 carts. And I don't remember how long I let them go for, but obviously more than 10 seconds. So we're going to take up to 10 seconds. Okay, so just do what I did, scroll down, okay, until you've got 4 carts and down to 10 seconds highlighted. And then you're simply going to cut that, so Control X. You're going to go to your spreadsheet file, first box, and paste. Okay, that's the data you're going to build your graph from. Okay, plain and simple, same as we did before. Insert your chart. Okay, that's not the kind of graph we want. That's a line chart. What do we want?
Scatter.
We want scatter. Okay, so go down to scatter. Okay, now you can see here that one of the issues we're going to have is that it made the points really big. Okay, we don't want the points that big. All right, and you can see that they're not perfectly linear either, and that's okay. They're generally linear. Okay, so you're going to have to do a couple of things. You don't have a label over here on the horizontal or on the vertical axis. You do have one on the horizontal, so make sure you do all of that changing in the Customize menu. Okay, that is position in meters. Okay, and we need to go to series. Okay, I'm going to change those pixels down to 2 so those points don't overlap each other so badly. Put in a trend line for each one, same as we have on all our other graphs, and then use the equation for our label. Okay, if you're getting behind, don't worry, I'm recording the whole thing. Okay, you can always come back and check it. All right, so there we go. We've got our equations for each line. Remember that this is saying that for cart 1, y equals 0.346 times x plus negative 0.184. Okay, so they've given you everything there. Okay, everything that you need. And I would also, guys, change the title of this. Okay, this title is terrible. Okay, once you've got that, you can copy it over into your lab reports. Okay, and then you can start on your analysis. Okay, so it shouldn't take you too long to get all of that. What did it take me? About 3-4 minutes. Okay, so hopefully the Wi-Fi improves here, okay, and you can get that kind of stuff done, okay, on there.